At this point, we've multiplied monomials by polynomials, we've multiplied polynomials by polynomials, and today we're going to discuss some what we call special products of polynomials, mostly sum of squares and difference of squares. So you'll see that what a sum of squares is we take and look at this binomial here, where we have a plus b quantity squared. Now what most people do is they think, well, I just square a and square b and I'm done. But that's really not what squaring means. Squaring means multiplying something by itself. So as you can see, if I were to multiply by FOILing, we'd have a squared, there's 1ab, and there's another ab, so that would make 2ab, and then b squared. Likewise, you can see by this example, multiplied out twice, there's x squared, 4x, another 4x, which is your 8x, and 16. So that's typically the sum of squares. And you'll notice that the last term is the square of 4, and the middle term, if you will, or x to the first term, is going to be 2 times that 4. Now, if we take a look at a difference of squares, again, we don't just square the a and square the b. We take and FOIL these, so we'd have our a squared, our minus ab, our minus ab, and our b squared term. And you'll notice again that same relationship, that the last term is the square of the two b's, but the middle term is 2 times the product of the two binomial terms. So let's go ahead and do a couple of these. If I want to find the product of 7z plus 2 quantity squared, I'm just going to write that out twice and then go about FOILing. So here's 49z squared, 14z, another 14z, and 4. So I have 49z squared, 28z, and 4. Noticing again, the last term is the square of the second term of the binomial, and the middle term is 2 times the product of the two coefficients in the binomial. So then we do the next problem. Again, big fan of writing this out twice. Going through and FOILing. So it's 9c squared minus 12c minus 12c plus 16, giving me 9c squared minus 24c plus 16. Last term, square of the second number in the binomial. Middle term, 2 times the product of the two binomial terms. Now we get to some word problems. We want to write an expression that represents the area of a square that has a side of length 3x plus 12. And we know that in a square all sides are equal, so this side must be 3x plus 12. And we're finding an area which is length times width, so that's 3x plus 12 quantity squared, and obviously they're going to want us to multiply this out. So let's go ahead and do that. We have 3x plus 12 multiplied by itself, and I'll FOIL all that information out. We have 9x squared plus 36x and another 36x and 144, giving us 9x squared plus 72x plus 144. So now in this case, this problem's a little bit different in that we don't have the same term squared. We have 1 plus, 1 minus. And we'll notice we have 81d squared minus 36d plus 36d minus 16. Now you'll notice in this case that these two middle terms are opposites, so they go away, and I'm just left with 81d squared minus 16. And that's what we call a difference of two perfect squares. Now in our last example, it talks about having a circular road around the monument, and we're going to try to find the actual area between these two roads. Now what they tell us is they tell us the inside radius, so from here to the inside of the road, is 10 meters less than the outside radius. So what we have is we have a comparison. If this outside radius, let's call this r, then this inside radius is r minus 10. And they want to know how much area is between the two. Well, to find the area between the two, we take the big area, subtract off the small area, and we have what's left. It's kind of like a donut principle, cut out the middle. So the big area, area large, let's call it, is equal to pi r squared. Small area is equal to pi times r minus 10, because that's the new radius, squared. And I can FOIL this term out, so this is pi r minus 10 times r minus 10, which gives me pi times r squared minus 10r minus 10r plus 10, plus 100. Distribute all that through, so I've got pi r squared minus 20r. There's a pi on that as well, plus 100 pi. And now what we have to do is we have to take the large area and subtract off the small. So large minus small equals the road. So the large is pi r squared. Subtract off the small area, which is pi r squared minus 20, we'll call it pi r, plus 100 pi. And I know at this point I'm going to want to distribute this imaginary negative 1 to all these terms. So what I have is pi r squared minus pi r squared plus 20 pi r minus 100 pi. The pi r squareds are like terms, so in this case those will go to 0, and I'm left with 20 pi r minus 100 pi. So really the whole trick of the day was just rewriting our squared term twice and FOILing. And noticing there was a pattern that the last term was the second term squared, the middle term was 2 times the product of the two terms in the binomial. And that's all there was to it.